Hi all. So I hope all of you are back from the break. So shall we start the next part on this? Okay. So next I will expect all of you to do it by yourself, right? So model is created, right? So we have seen how the model is created and we have seen how to see that decision tree with the help of rpart.plot, right? And we have also seen how to plot and understand that how you can create that part of this this, what do you call it as, your the decision tree and the complexity parameter chart also we have seen. Now can you predict the data based on this? Now let us see who will be able to do it. You will have to predict, right? So we will create a variable of predict, okay, or we will call it predictor, okay, and in this we will be using predict function. Correct? This is the function that we use always, predict. And what is the model that we have created? Based on the model tree, this is something, the model that we will be using. And then what data set we will be using in this case? Data set is testing, okay, test data set. So you will use testing as the data set over here. Anything else that we need to use in this over here? Okay, right, Sachi. That is type, right? Type equal to class. Now that is something that is very, very important. Okay, so we will be saying type equal to class. So there we go, predictors are created and we can see predictor. So we can see the output has been created for us, yes and no. Okay, all of you please do this, and then you all have to do one thing, that is calculate the accuracy. So please do this part. Anyone who has calculated the accuracy? So you're saying 54%. Okay. Others? So what we can do is we have a training data set. So we can say training, sorry, testing dollar. Let's create a new variable that is prediction, which is nothing, but that is equal to predictor. Right. So if we will check the testing data set now, we shall be able to see that we have churn and prediction. Okay, let us create a table on that. So I can say I would like to create a table in which I will use testing dollar churn and testing dollar prediction. So this is the number that we are getting. Okay, so if I just add up these numbers, right? So what you can do is, actually I will just show you a function of doing that. How you can actually, without writing that step by yourself, what you can do is you can write, you want to find the sum of diagonal of this table. Okay, what this will do is this function will do one thing for you. It will give you the sum of diagonals. 2,666, right? That is what the total that you are getting. 2,666 is the sum of the diagonals. What we will do now is we have to divide this 2,666 by how many rows do we have? We have 3,700 rows, right? In the testing data set, we have 3,700 rows total. So 72%, right? This is what the accuracy is correct. So the model is giving us the accuracy of 72%. So Rishabh, is there something wrong in your calculation that has happened? You are saying to be it as 54%, but I have got this is coming as 72%. There's a big difference that I can see. Okay, see what I've done is I've just said diagonals, take the diagonal values and find the sum of that. So that gives you 2,666, and then I divided that by the total number of rows. And in fact, I will give you one more shortcut way of doing the same thing. You can also use this command, right? This is the command that we are having, table command that we are using right now. In this table command, what you can do is you can use one command on top of this, that is prop.table. That is proportion of the table. It gives you the output in the form of percentage. See, it is giving the output in the form of percentage. 42% no to no, 12% no to yes, then 15% yes to no, and 30%. If you will add up all these together, this will give you 100% to 100%. So if you just add this 42 plus 30, that gives you 72%. So you're getting an accuracy of 72% in this case. Okay, so this is how the decision tree model is created, right? So we have seen pruning, right? So now pruning is something that you can define previously also, or maybe, after you have created the tree, you can define that, I would like to keep a maximum depth of this, or you can define, I would like to keep a CP equal to 0.02, whatever value you decide, you can do that, right? So you can just create this again, and again, you can check the model accuracy and everything. Okay. So all of you, please create and calculate the accuracy and let me know if you are having any troubles in doing that. Yep. Are you all getting this? Okay, so Raghu, you are getting a 71. So this is almost similar only, right? 71.35, because this is the random data set that we have created. So your data set could be little, but yeah, definitely it should not be very much far apart. Yep, everyone. Are you all with me? See, now, next as a next test, as a task, what you can all do is you can try to create the same model with logistic regression also, right? And you can check the accuracy with that. See, everything will remain the same because data is already cleaned. You already have a training and test data set. Everything is with you. The only thing that you have to change is you have to change the modeling technique in this. So instead of creating this model with the help of R part, you will create the same model with logistic regression. And then you will see how much accuracy are you getting with that. Now, this is the same technique that we follow in the industry also. So we will see, okay, logistic regression, because see, EDA part will remain the same. Nothing needs to be changed. Only at this part, my function will change. That's it. And in the current data set also, if you will see, we have a binomial data. We have yes and no. Had it been that we had yes, no, and others, definitely logistic regression couldn't have been used in this case. But in this case, since we have only two kind of classes, I can use logistic regression also in this case. Will you like to all try this? Maybe, you can, I will just like to give you this as a home task. Okay, try to create the same model with the logistic regression and create its, this, just check the accuracy, and we will discuss on that tomorrow. Okay. And in a similar fashion, the model that we developed in logistic regression, right? The model of the bank default, over there we created the model using the LR, create that same, work on that same project and create it with the help of decision trees now and check the accuracy, right? So now you have seen so many tasks that you can just use with the existing projects only. You can try to change the models now and you can see how the accuracy is changing, and then you can suggest which model should be used for this predictive modeling. Okay. So with this, we come to the end of the third modeling technique that we have learned now over here. Okay, so we have kind of done the stuff on the side of, we have learned the part of linear regression, linear, logistic, and decision trees. The next technique that we are going to learn over here is, that is the LDA, right? That stands for linear discriminant analysis. Okay. So Bhubaneswar, you're getting error in. I mean, this is which command have you executed? Can you share that command, Bhubaneswar, please, over here? Which command have you executed over here? Actually, you are adding the variable in the churn data set. You have to add it in the test data set. Right? Okay. So shall I move ahead? Shall I start with LDA, or shall I wait for all of you if you have any queries, doubts, or any errors that you're having? Do you want me to wait, or shall I start? Okay. So let me just start with that. Just give me a moment. Now this LDA is very easy, right? This is something very simple technique that we have. Okay, so let us try to understand the linear discriminant analysis over here. Okay, so what we will do is, let me just start with a small example over here. So now this LDA, the approach that we will be kind of exploring over here. Now this is also one of the techniques that we use for classification purposes only. Okay, this is also a model that we use and built up for the classification model. So, but what is different, right? How is it different from the logistic regression, and how it is different from the decision trees? That we will just discuss that in a little bit of a while. So let's try to understand a small business scenario, a small example. Say suppose there are, you launched some advertisement campaign. Okay, maybe you got some pamphlets to be printed out. You got some pamphlets with you. So you kind of got printed 1 lakh, the pamphlets, and now you distributed those 1 lakh pamphlets to 1 lakh different people. Okay, Now, only 1,000 of those people came to purchase your product, right? Out of the 1,000 people to whom you distribute your pamphlet, only 1,000 came up to buy your product. Now, if let us assume that, say, suppose the cost of one pamphlet was $2. Okay. So how much money did you spend? You spent around $2 lakh on the pamphlets and you got only 1,000 customers. So what is the cost of acquiring one customer in that case? What is the cost of acquiring one customer? So you got 1 lakh pamphlets and the cost of one pamphlet was $2. Okay. And so what was the cost of acquiring a new customer, because you only got 1,000 customers? So kind of you had to spend $200, right? In order to acquire one customer, you had to spend $200. Now, the reason that we need, or the purpose that we need these classification model is so that what can happen is that if suppose you have to do some analysis on the data, that before selling those 1 lakh, what you should do, what your target should be, that instead of distributing your pamphlet to the 1 lakh people, what if you just distribute your pamphlet to 20,000 people after some analysis, and you want to target a people on whom you have higher probability that okay, they will buy it. Now out of those 20,000 people, if suppose 900 people buy it, right? So your cost will come significantly down, right, of acquiring a new customer. Now this is the same thing, the companies actually do this sort of analysis, that when they spend so much of money on the marketing, then how many new customers they have gained. That is something that their prime motive is, because if suppose they're just spending money endlessly and they're not getting any significant customers, so that is like a waste of money. Okay, so that is the whole purpose of classification model, is that this is something that we have seen in the telephone churn also, right? The telecom churn analysis that we saw, that how many people will leave the company and how many will not. If the companies can do that analysis beforehand, so they will be in a good position to take some strategic decisions before that loss happens. Now similar is the concept that we will be using over here as well. Okay, so just a small example over here. So if you see over here, the goal is that if you have a population of n and k are the people, number of k means the people who have responded and purchased your product. So what we want to do over here is that we want to create a model, and on the basis of that model, what we should be able to do is we should be able to identify a good proportion of people on whom we can spend our money on promotion, and ultimately we should be getting some return, and a better return as compared to doing that, the marketing blindly. So that is where this you will actually see, and kind of you would have seen that when you go to any of the very hi-fi model or the malls, right? Like if you go to very expensive malls or you go to some malls which are very popular, you would have seen over there, you will see some good brands of car companies. They are they advertise their cars over there, but you will not find high-end cars to be advertised in low-end models, right? Shopping malls, if you go in a low-end model, you will not find the car models being advertised over there, because they have done their analysis that what kind of people come over there, what is the what is the segment of the people, and they are trying to target the people who will actually buy their product. So that is how that the marketing campaigns and everything works in the industry. So this is why the classification models are so widely used, right? Because yes and no, whether a person will buy my product or not. So this is something common for any business. Any business you pick up the business of real estate, right? Whether a person will buy my house or not. You pick up the automobile industry, whether a person will buy my car or not, right? You pick up the e-commerce industry, whether the person will buy the products or not. So every industry is something that relies on the classification models a lot these days, right? So that is why you will see there are many modeling techniques that are available for the classification, right? This is the third technique that we will be exploring over here, which will be used just for the purpose of classification. So what is the purpose of LP? Because we have already two models that we have already discussed, which are used for the classification. So what is the use of, how is LDA different from the previous two that we have studied? So now basically we will be learning LDA model for two of the reasons. Okay, we will be understanding two things from here. One is LDA can be used for variable selection and LDA can be used for the classification of the data. So there are two reasons for which LDA is used. So when I say variable selection, right? So how do we do the variable selection in the previous three models that we have learned? Can anyone tell me? What was the approach that we used to use in order to identify the significant variables? What approach did we use? Right, Ayush, that was the p-value. Okay, so what companies do is, what we did in the model was, we were using p-value. So yes, Bhuvnesh, Gini index is one, but Gini index is something specific to decision trees, right? And when we worked on the linear regression and the logistic regression, over there we were identifying the p-value. The variables that were having high p-values, we used to discard them, right? We used to only keep those variables which had low p-values with them, right? So that is how we were doing the feature selection. But the process can become really hectic if you have lots and lots of variables, right? Because if you have, say, suppose hundreds of variables and you put all the variables into your model, and your data set is really big, you are having millions of rows to deal with. So what will happen in that case is you will, and your system will take a lot of time to give you the result, right? Because it will be, computing all the mathematical stuff on all the variables, and then it will give you the result. So in that case, it is recommended that, before running the model, what if I can identify the significant variables beforehand? Okay, before creating a model, if I can identify, okay, these are the significant variables, these are the ones that I should be using in my model creation. So that will actually make my job a lot easy, and I will be able to, compute my results at a faster pace. So that is one of the reasons where LDA is used for variable selection. And second is classification. Definitely, we can use this technique to classify whether a person will buy or not. So over there also LDA can be used without any harm. Okay. So you can use this LDA technique for binary classification also, and more than two classes also. So it is also one of the alternatives for logistic regression and decision trees. Okay. Let us take a small example over here to understand this better. So suppose I have the data of the people who own a mower, right? Mower is something that we use to cut the grass. Okay, now there is a company who wanted to understand that what kind of customers will buy a mower and what kind of customers will not buy a mower, right? A grass cutting machine. So what they did was they collected the data of some of the employees. Okay, they collected the data for some of the employees. And where this saw was, so they collected the data for two of the things, lot size and income. Okay, lot size as in the area that they are having, the garden area that they are having in front of their house. What is the lot size and what is their income? So what they did was, when they plotted this chart, they saw something that the owners, right? Owners are which are shown by the red color, and the known owners are the ones which are shown in the blue color. So it was observed that the people who are already owning a mower, they are those people who have high income and high lot size. Can I say that? If a customer is having higher income and he is having a higher lot size, can I say that he owns a mower, right? This is something that I can tell right away from this chart also. Okay, right. So what we do in this now is, this is the chart. If I try to create a linear line, or if I try to create a straight line, okay, if I try to create a straight line which passes from the center of this data, okay, so I can say anything that is lying above the line, that is a owner, and anything that is lying below the line, that is a known owner. Can I say that? Right, so I'm just creating a threshold line between this from this data set, from which I can tell whether a person is a owner or a known owner. Okay, is there any error that I will get if I create this line? Is there any error that I can get? So what is the error rate? What is the error rate that I'm having in this? What is the misclassification or the error rate? Yes, Bhuvneshri, the question that you asked, is it a way to find the right population for? Yes, you can do that. See, the technique that we use generally in that case is that is the clustering technique, right? You can identify which segment of customers are highly are very likely to buy your product, right? That is high. That is something that is done with the help of clustering technique. So, which is a unsupervised learning, right? So, all the techniques that we have learned up till now, they are more like supervised learning that we are doing. In the unsupervised, what happens is the clustering technique that we use in order to identify that. So clustering is a technique, you will all be learning in your Python trainings in a lot of detail. Right, so we can see three, right? So there is a three errors that we are having, right? These two, the blue ones, and one red on this side, right? So there are total of 24 points. So if I have to find the error rate, that is 3 by 24, okay, which will come as, if I just divide that, so 3 divided by 24, so that is 12.5%, right? That is the error rate that I'm having. Okay, so there are 24 points on this, and 3 are being misclassified. Okay, now this is a similar approach that is used in the LDA, right? Many of you might not have noticed in this, but the key thing to observe in this example that I have shown you over here is, if you will see on x-axis and on y-axis, on both the axes I have a continuous data. Okay, I have a continuous and a numerical data that I'm having on both the axes. Now that is how this LDA technique is different from logistic regression and decision trees. Now LDA is the best technique to use if all the variables, right, all your predictor variables are numeric, but you have to, your target variable is classifier. If your output is in the form of a yes and no, but all the other variables are numeric in nature, that is where LDA can be used for the higher accuracy rates. Are you all getting my point? Right? You have one data set in your R also, which comes as pre-built, and that data set is, let me just show you that. That is IRIS. This is the data set. If you will see, sepal length, sepal width, petal length, petal width, and species. Say suppose you have to create a model and you have to predict which species of that plant will be based on their length, width, petal length, petal width. Now this is the data. You can see all these variables. We do not have any categorical variable over here like gender, country, or something like that. All the variables are numeric, right? For such kind of data sets, LDA is the highly recommended model that we should be creating. Are we all clear with this up till this point? Okay. Okay. So what we do in this case is, right, like how we use this LDA model is, see, LDA is also something that will calculate the percentages only. In this also what it will do is, if suppose you have class of data, right? Say suppose you have an example that if a customer walks into a store, what kind of product will he buy? Will he buy a equipment? Will he buy something related to the entertainment, or he will buy both? So in the LDA approach, what happen is, what LDA model will do is, it will give a score. What is the score that he will buy equipment? What is the score he will buy entertainment? What is the score he will buy both? Now, higher the score, it will predict that category, right? For example, if person one walks into the store, so it will calculate the score of buying the, say suppose blue, you have this legends also over here. So blue means equipment. It will calculate, okay, if a person one walks into the store, his score of buying the equipment is around 4.5. His score of buying the entertainment is around 2.5, and his score of buying both the items is coming as to be 5. So the score is coming highest for both. So your model will predict that this customer will buy both the items. Similarly, it comes to the second customer. For the second customer, it sees the score is coming highest for equipment. So it will predict the customer will purchase equipment. Similarly, over here, the score is coming highest for entertainment. So over here, the model will predict that the customer will buy the entertainment stuff, right? So this is how the LDA approach works. Okay, it gives the scores, and based on that class, higher the score, that is the prediction that this model will do. Okay. So what is LDA? LDA is all about using numerical data to decide about a categorical outcome. Okay. Based on the numerical nature of a data, you are trying to predict something in the categorical nature. That is where we use the linear discriminant analysis. It is very useful, and when it is reasonable to believe that the independent variables are normally distributed. Now, this is an assumption that we take, that we have an assumption that the independent variables are normally distributed. Okay. It also assumes that the correlation among predictor within a class is the same across all the classes. Okay, so it assumes that the correlation is similar, right? Like for example, if you pick up the data for yes, correlation of the variable is similar in the yes and no. Okay, so it will pick the two classes. If you're talking about binomial data, you have two class, yes and no. What this model will do is, this will say, okay, if the class is yes and you pick up the first target variable, it will say, okay, the correlation is 1. For no also, it will assume we have an assumption that for no also the correlation will be 1 only, right? The correlation of the predictor within a class is the same across all classes. You can use your this LDA for more than 2 categories also, and logistic regression and the diffusion trees technique that we have used, they are similar to EDA, right? So this is also that can be used as an alternative to that. And it is unreasonable to expect normality of independent variables. You prefer logistic regression over LDA. Okay, so if you think that the data is not normally distributed, so you should be using logistic regression over LDA, right? So if you think that the data, as we have said, right, all your numerical data should be normally distributed. If you think the data is not normally distributed, in that case, you should be using logistic regression over LDA. Okay. Right. Any questions, anyone up till here? Anything that you would like to feel is not clear? ANOVA is the analysis of the variation. Okay, that if suppose you are, the example of that is, say suppose you have two machines, right? That you have two machines which are dispensing the cold drinks in the company, in any company. Okay, so as an assumption, right? What we have an assumption is that both the machines will be giving same amount of cold drink. If you fill your glass from your machine one, in that case also it should be 300 ml. If you fill your glass from the second machine, that also it should be 300 ml. It should not happen. Both the machines are having some variation. Okay, that is where we use ANOVA. So analysis of variation, how much variation do you have between the two machines when you fill your glasses below that? That is called as an analysis of variation. Okay. Now, see, now this is a small example. I'll just come to it in a little bit of a part. Okay. Yes, Trisha. So you will only have to use numerical data for that. You will have to keep only numerical variables. Only then you will be able to use this the LDA in that churn analysis. And by which any which way, what will happen is you will end up, reducing down your data set, and your accuracy will not be that great. Okay. Now see, there is a small representation that you can see over here. Okay, can you all see this? So there is a small definition. This is just a chart to help you understand which kind of analysis you should be using for what kind of data, right? If your independent variables are categorical and you have your predictor are also categorical, you should be using classification tree, right? This model is the best to be used. If all your independent variables are numeric and you have to predict something that is categorical, you can use logistic regression, LDA, support vector mechanisms, or RT. So there are these kind of models that can be used. If in case your independent variable and dependent variable both are numeric, in that case you should use linear regression. This is just a small diagram to help you out to decide what kind of model works the best with what kind of data, right? These are the four combinations that you can have, right? If suppose your data is categorical and you have to predict the data that you have to predict that is numeric, in that case you should be using a regression tree, right? So LDA is something that you should be using in the case when your variables, the independent variables are numeric, but the predictions are categorical. That is where a linear discriminant analysis is something that will be very, very useful for all of you. Okay, so this is a small table. I will upload this file on the drive also, right? I will just upload this PDF on the Google Drive, so you can all go through it and use this as a reference. Okay, so this is where this diagram can help you in terms of deciding which model to use when. Okay. So I think for today, I will just keep the stuff up till here, because tomorrow we will do all these things practically. First, we will see how to use the LDA model for the purpose of the variable identification. We will do that stuff, and then we will see how we can use the LDA model for the classification problem. Okay, so that is how we will take up the things ahead from there. So till then, as a home task that I have given you, try your models with the logistic regression and logistic model with decision trees, just to get the flavor that how the things are changing, and try to interpret the results in that case. Okay. Okay, class. So see you tomorrow then from here. And I'll just upload this file also in the meantime on the Google Drive.